Hello class, this is Mrs. Albritton of Albritton's Math Class, AMC. So this video is helping you out with your practice test that you received to get ready for this week's quiz. The quiz that we're going to be taking this week is on complex numbers. We will be adding, subtracting, multiplying, and dividing them. We will also be asked to simplify a few negative square roots, and we're going to look at the exponential rules and laws that we learned about earlier. So let's get started. Problem number one wants us to simplify the square root of negative 49. Now, all of us have experienced simplifying positive square roots, but what about negative square roots? Now we know how to do those. Why? Because we learned about something called imaginary numbers, and we found out that the imaginary number or unit I is equal to the square root of negative 1. So we're going to apply that to this problem. Now, the first thing that I'm going to do is I'm going to break this number down into factors. So I can rewrite this as the square root of 49, positive 49, times the square root of negative 1. Well, the square root of 49 is a perfect square. It is equal to 7. And now that I know about imaginary numbers and I know that I is equal to the square root of negative 1, I can go ahead and put I right there. And then there's my answer. It is 7I. The I, the imaginary number or the imaginary unit, accounts for the negative. Okay? Let's take a look at number 2. Now number 2, we're taking a negative square root times another negative square root. And again, we want to go ahead and break those apart. Recall that when we actually simplify positive square roots, we look for factors of that number, of the radicand. And what we're looking for is any perfect square factors, because that makes it easier to simplify. So when I break apart the square root of negative 20, I want to look for some factors of 20 that maybe, hopefully, the one that will give us a perfect square factor. So I'm going to I already know what it is. So I'm going to rewrite this one as, and I'll put it up underneath here. So I'm going to rewrite the square root of negative 20 as the square root of 4 times the square root of 5 times the square root of negative 1. Now I wanted to go ahead and separate those. Sometimes we'll put all of these factors up underneath the same radical sign, but this time I wanted to keep them separate because of this imaginary unit that we're dealing with. So I've broken this one apart. Now let me multiply that by this one. So I'm going to go ahead and break that down into some factors. And it just so happens that 32 has a perfect square factor. So this will become the square root of 16 times the square root of 2. And then I've got to account for that negative value. So if you notice, I've got 4 times 5 is 20 times negative 1 gives me my negative 20. 16 times 2 is 32 times negative 1 is negative 32. So what can we do with these? Well, notice that in this one, I have a perfect square. The square root of 4 gives me 2. Now the square root of 5, I've got to keep it as is. And then the square root of negative 1 is the value of I. So I'm going to put this right here. So square root of negative 20 gave me this result. And then I've got to times it by square root of negative 32. Square root of 16 is perfect, gives me 4. Square root of 2 has to just stay as is because it cannot be simplified any further. And the square root of negative 1 is I. I'm going to put the I right with the whole numbers. So I've got everything I need. I've broken this apart and that apart. Now let me simplify even further, because remember, if it says simplify, you keep going until you can't do anything more. So here I'm going to multiply what I can multiply together. In other words, I'm going to multiply the common terms together. What do I mean? 2i times 4i gives me 8i squared, because 2 times 4 is 8. I times I is I squared. And then the square root of 5 times the square root of 2 gives me the square root of 10. And I'm almost done, because remember, we have learned some information about imaginary numbers. I squared is equal to negative 1. I have an I squared, so I've got to replace it with negative 1 and keep it moving. So here I'm going to have 8 times negative 1 times the square root of 10. And my final answer will be negative 8 times the square root of 10. So now I'm done. All right, let's look at number 3. Number 3 is similar to 2. Now, the only difference is that square root of negative 10, I can't simplify that. It's already as simple as it can get. So I'm going to leave this here, bring this on down, square root of negative 10, but I can do something with this one. Oh, I'm going to go ahead and write down times the square root of negative 1, because I do have to account for my negative. Times, here's a perfect square, isn't it? The square root of 36 is 6. But then I've got to do similar to what I did here and account for that negative by using my imaginary I. So I'm going to go ahead and call this 6i. All right, so what I've ended up with here is the square root of 10, and then there's this value gives me I times 6i. When I multiply what I can put together, I can put together I times 6i, which is 6i squared, and then I've got to bring this over. Don't leave it out here by itself, so it comes over as part of the solution. Am I finished? Not yet, because I've got I squared equals negative 1, and look, there's an I squared. So we've got to use it. It's become 6 times negative 1 times the square root of 10, and my final answer, 6 times negative 1 is negative 6, and bring over my square root of 10. So there's the final answer. So far we have this. So take a look at your paper and just check and see, did you get the same answer? If not, look back through the problem and see where you may have went wrong, and then go ahead and correct it. Let's look at number 4. So for number 4, all I'm doing here is, so there's no more radicals, but I'm multiplying negative 3i times 4i times negative 5i. Now, the strategy that I like to use is I just like to do 2 at a time. So I multiply 2 terms at a time. I'm going to go ahead and do negative 3i times 4i, which is a negative 12i squared. Because negative 3 times 4 is 12, and I times I is I squared. Now I'm going to go ahead and bring in the last term, negative 5i. And let's work this out. Negative 12 times negative 5. A negative times a negative gives us a positive. 12 times 5 is 60. So this is positive 60. Now I still have my I squared and my I here. So I squared times I is I to the 3rd power. Okay, do we know anything about I to the 3rd power? We do now. It's equal to a negative I. So I'm going to replace that with negative I. This becomes 60 times negative I. And when I multiply any positive times a negative, I'm going to end up with a negative 60i. So here's my final answer for number 4. Okay, and let's look at the last problem, number 5. Okay, similar to this problem, except notice that we have one of our exponential rules going on here. We have a product of a power, because there's a product in here. 7i means 7 times I, and then it's raised to the 2nd power. Now, if you remember, or if you look on your notes, when you've got a product power, we literally distribute that exponent or power to both of the terms in here. So I'm going to rewrite this part as 7 squared times I squared. See how I can distribute it to 2 to the 7 and to the I? And then I'm going to go ahead and bring down times 6i here. So let's do this work. So here we have 7 squared is 49. What is I squared? Negative 1. And then we've got 6i. Are we done? No, because we can still multiply some things. See, 49 times 6, that's going to give us 294 times a -1 times I. So I don't know if you know, but -1 times I is -I. So this is -I. And then the final answer, when I multiply this positive times that negative, because remember now, we can assume that there's a 1 in front of there. We just don't have to write it. It's assumed to be there. So that's like 294 times -1, which is -294. And I. Here is our answer for number 5. So take a look at your work, either verify your answer or make corrections to your answer. And then we'll look at numbers 6 through 10. Okay?